Hi everybody, this is Sean Corcoran. I'm a professor at Vanderbilt University, and this is my crash course introduction to Stata. This is my first time doing a instructional video of this type, so forgive me if this isn't quite as slick as your favorite YouTube channel. So I'm working here in Stata MP version 15.1. MP stands for multiprocessor. There are different versions of Stata, including Stata IC and Stata SE, that are slightly less powerful, less expensive. For most purposes, though, any version of Stata will work well, and anything that I do in this presentation will work in all of these versions of Stata. The first thing I want to show you is Stata's interface, which is what we're looking at right now. Here at the bottom is the command window. This is where one might work in interactive mode, where you would type commands and see the results here in the middle, which is called the output window. On the left-hand side of the screen is the review window, where commands that I've issued in the past will show up. I can recall those commands. I'll show you how to do that later. In the upper right-hand corner is the variables window that will show you a list of variables that are in memory. Currently, there's not a data set in memory, so you won't see any variables listed there. And the lower right-hand corner is the properties window, which will show you properties of both the data set and individual variables. This is where I have these windows positioned. It is possible to customize this. You can unpin these windows and move them around where you like them best, but I like the setup that I have right here. As I mentioned, there's at least one way to interact with Stata, which is the interactive mode using the command window. There is another way of interacting with Stata, which is what you might call batch mode, using the do file editor. So I'm going to flip over to the do file editor. The do file is just a text file. It's called a do file because the file extension is .do. The do file is just a text file, which is a script, a list of commands that you can run as a batch. Most researchers doing statistical work will be working in the do file editor. The reason for this is that programs can often extend to thousands of lines of code. It's better for debugging. It's obviously faster and allows you to recreate work later on that you've done in the past. So I'm going to recommend, much of what I'll do today is using the command window, but going forward I would recommend that you use the do file editor. I'll just show you one quick do file that I've created. This is 2020, the area of the coronavirus. I created a do file that will reach out to the New York Times database and pull in the number of COVID cases by day for both the US as well as states and individual counties. And this is a do file that will read in the data, analyze it, and produce a nice line graph. Maybe I'll show you that later. But back to the Stata interface. A couple of really basic commands. You can type version at any time and find out which version of Stata you're working in. This is again version 15.1. Stata, I think, is currently up to version 16. You can check for updates. So if I type the word update, I can get a prompt to check for available updates, or I could type update query, which will reach out to the Stata server and determine whether your version of Stata is ready for an update. Mine does not appear to be ready for an update. You could go straight to update all, which is a command that would fully update your installation of Stata. But again, there's nothing to be done in my particular case. Stata's help windows are really helpful. You can type help and a keyword, help and a command name. I just showed you the update command, so maybe I'll type help update. That takes you to Stata's help menu. The structure of Stata help menus is consistent from one page to the next. So for a help menu on a Stata command, you typically see the syntax for that command at the top, some different examples of how that command might be used, a detailed description, and often links to even more information in the PDF documentation online. Again, you might find these a little bit dry initially, but they're really well done. Something else that'd be useful to show you at this point is the ability to use Stata as a calculator. Right? So if I were to type display 2 plus 2, Stata will return 4. You might ask, why would I need to use Stata as a calculator? I think you'll find as you proceed through this work that this is actually a really useful command. Right? I can do more sophisticated calculations, right, using functions. Right? So I could ask Stata to give me the square root of 49 plus 10. Right? So sqrt with 49 in parentheses, so the square root is a function. Display can also be used with strings. Right? So if I were to type display hello with hello in quotes, Stata would return hello. Again, seems kind of silly, but you'll find applications for this in the future. This is a good time to point out that Stata will accept abbreviations. So if I were to type di 2 plus 2, I get the same result as if I type the full word display. You're free to use abbreviations and use as few letters as you like, so long as the abbreviation is unique to that particular command. Right? So if an abbreviation doesn't differentiate between two commands that start with the same letters, you'll get an error message. I typically use 3 letters anytime I'm abbreviating, or I don't abbreviate at all. Up to you. Let me show you the common mathematical symbols. Right? So Stata has addition, subtraction, standard use of parentheses, multiplication, and division. Obviously, it pays to use parentheses anytime you want to make the order of operations clear. To get a full list of mathematical functions, type help functions. Right? I've been doing mathematical functions, right, like square root, but there are countless other mathematical functions you might want to use. There are string functions for string type variables. There's date time functions for, obviously, for dates and times. There's random number functions, statistical functions, trig functions, etc. So you can get a complete list by going to help functions. So let's talk about Stata data files. So data files are files that end in .dta, right? And for this video, I'm going to be working with an extract from the National Education Longitudinal Study, the NELS. So NELS.dta. The NELS was a large-scale longitudinal survey of 8th grade students that followed them through high school and into college and into the workforce. It included tens of thousands of students. This is a small extract from that data set with 500 students and a small subset of the variables that were in the original data set. If you look in the lower right-hand corner, you see that NELS.dta popped into this data window. You can see that there are 500 observations and there are 48 variables. It also shows you how large the data set is in terms of disk space. 9 times out of 10, you won't need to look at the data in this way, but if you want to look at the underlying data directly, there's a couple buttons up here, which is the data editor. One is data editor edit, and the other is data editor browse. So I'll click on the browse, and it pulls up the Stata data file. It looks exactly like a spreadsheet, right? Each row in this window is a student observation, and each column is a variable, an observation on that variable for that particular student. Right, so you can scroll around and inspect the data that you're working with. You can also edit data directly if you click on the Data Editor Edit button. Right, so if I wanted to change this ID number to 1,000, I could do that just as if I was working in a spreadsheet. Generally, I don't recommend that anyone do this because you're essentially just making ad hoc changes to the data set that won't be reflected anywhere in your do file, for example, right? So I always recommend keeping data sets intact, and any changes that you make to the actual data set, that you document those in a do file. Right? You never know when you might make a mistake and then that mistake is unrecoverable. Right? That's worth pointing out that there's no undo function in Stata, so it's not like Excel in that sense where you can just undo your prior actions. Right? But you will notice that everything that I'm doing is being logged over here in the review window. Right? So here's where I opened the data set. Here's where I actually replaced the first observation ID number. Right? I'll mention right now that you can, in the command window, you can page up and page down if you want to go back and re-execute a command that you submitted in the past. Right? You can also double-click a command that you submitted in the left-hand side to execute the command again. Okay, so back here at this step, I opened the NELS dataset, and the command to open a data file in Stata is use, USE, right? And so I have the full file path here in my use command, in quotes. The use command, a file name does not require quotes unless there's a space in that file specification, right? So if I were to try to, I'm going to set clear. Clear will remove that data set from memory. If I were to submit this command without quotes and there's a space in the file path, I'm going to get an error message, right? As a general rule, I tend to put quotes around all file names and file paths, regardless of whether there's a quote, whether there's a space or not. All right, so you just saw me use the clear command, which will erase the data set from memory. You should do this with caution because you don't get a pop-up window that says, are you sure you want to do this? And clear will remove the data from memory without saving any changes that you may have made, right? So if you make alterations to this data set, if you create new variables, what have you, you will want to go in and actually save that data set before clearing it out, right? So like in other software packages, you can save as and save to a particular file location, or you can click on save and you're prompted to overwrite the existing file. If I wanted to do this directly in the command window as opposed to the drop-down menus, I could just type the word save and the file name. Notice I get an error message with that particular command. This is preventing me from overwriting the file that already exists. If I were to add comma replace to the end of the command, it will overwrite the existing file. This is a good time to point out that commands often have options associated with them, many options in many cases. These options always follow the comma at the end of a command. So you'll see a lot of examples of that. Let me show you one more example of that. Let's open the NELS file again and tell Stata that we want to clear whatever happens to be in memory at this time. So comma clear will clear out whatever data is in memory and will replace it with the file name in this use command. I'll come back to the NELS dataset in a second, but I wanted to mention that Stata has a number of built-in datasets which are great to use when learning Stata or to play around with new Stata commands. So you can find them under example datasets. So some of these datasets are installed with Stata. The one that you see time and time again used in Stata documentation is the auto dataset. There we go. So the auto dataset is a dataset of different types of cars with their specifications, miles per gallon, price, etc. Right? You'll notice that the command that was issued to Stata is sysuse auto, so like system use. It loads a pre-installed dataset into Stata's memory. So I'm going to clear this out, and I'm going to go back to the NELS dataset by double-clicking on the use command issued earlier. All right. So now that we've got a data set in memory, we may want to take a deeper dive into the data and see what the data looks like. I already showed you the data editor browse button. I'll show you a few other commands that can be used to just inspect the data set in memory. So one that's not used very often is just the command called list. List is just going to dump the entire data set to the output window. That's not going to be helpful for most data sets. You could type list in 1/10. This is telling Stata that you only want to list observations 1 through 10. Now this suffix in, a/b is an option that you can use for really any Stata command if you only want to apply that command to the first 10 observations, right? Or perhaps I want to do observations 10 through 20. I can do that as well, right? So if I just want to see a short list of the first 10 observations, say, I can add in 1/10 to the list command, right? I can also add specific variables to the browse command. Browse, sorry, I should have mentioned this earlier, but browse is one way to open up that data editor in browse mode. If I wanted to browse but only look at, say, the first 5 variables, I can type the command browse and then list the first 5 variables. Whoops, I'm missing ID. Notice that I'm double clicking on the variable names. There we go. And it's dropping them down into the command window. That's a really handy feature of Stata because sometimes variable names are kind of awkwardly spelled, and to ensure that you don't make a typo, you can just double click on the name of the variable. So submit that command, and the data editor window pops up with just those 5 variables. I could combine these two and add in 1/10. So I did this with the list command. I could do this with the browse command and just view the first 10 observations. Another helpful command for getting acquainted with a data set that's in memory is describe. Describe is like a table of contents, and so this is going to give you a list of all of the variables contained in the data set with other information, including a descriptive label, the type of variable, so there are numeric and string type variables, and the numeric variables can be stored in different formats or storage types. You'll see that this variable name ID is an integer type variable. This advanced math 8 variable is a byte type variable. Byte is just sort of a single digit, for example. I'll come back and talk about these value labels later, but these are descriptive labels that are attached to numeric values. And up at the top, you see there's, again, 500 observations here, 48 variables, and this is the amount of space taken up on the disk. Again, you could select only a short list of variables if you want to just describe that list of variables. So I'm describing 4 variables in this case. If you want to get really basic information about the data set, you can type describe, short, and that just gives you the observation count, the number of variables, and so on. Notice again that I abbreviated describe with the first 4 letters. Another command I like to use is codebook. You could do codebook by itself and get a lot of detailed information about every variable in the data set, or you could type codebook and say one of your variables, in this case region, and get information about that variable. So for example, region ranges in values from 1 to 4. There's 4 unique values of region. None of them are missing, a good way to find out if there are any missing data in that particular variable. And it will show you the labels that are actually attached to these 4 values. So 1 is the northeast region, 2 is the north central, 3 is the south, and 4 is the west. And you get a little frequency distribution along with that. So I use codebook a lot. That's pretty valuable. A related command is inspect. You could type inspect region. This gives you a quick breakdown on the number of positive values, negative values, zeros, and missing. helpful if you just need a quick look at one of the variables in your data set. Count, as the name suggests, counts the number of observations. I use that more often than you might expect. I can also put a if clause on a command. So if I wanted to count the number of cases where region is equal to 1, I could add if region equals 1 to this command. So there are 106 observations or cases where region is equal to 1. We saw that earlier under codebook. You'll notice that when I put this equals command that I used a double equals sign. So if you're using an if condition where something is equal to something, Stata requires that you use a double equals sign. If you do not, you're going to get an error message. And this is probably one of the most common bugs in a do file, especially among Stata beginners, is to accidentally use one equal sign instead of two. And this only applies if you're using it in an if condition like this. Stata is case sensitive, so my region variable is in all lowercase. And so if I were to type count if region equals 1 with a capital R, it's going to tell me region is not found because there is no variable region with a capital R. Right? So as a general rule, I like to restrict my variable names to be strictly lowercase, and then I really never run into this problem. So Stata is case sensitive when it comes to variable names. Okay, and now some commands for descriptive statistics. One of the most commonly used commands is summarize, right? So if I want to get, for example, the mean and standard deviation of a variable, let's look at the self-concept score. So this SLF CNC08 is a self-concept score for students in 8th grade. Not important how that's measured at this point, but summarize variable name will provide the mean, standard deviation, minimum, and maximum. Summarize has a number of options, and one of them is detail. So if I put comma detail at the end of the summarize command, I'm going to get a little bit richer description of this self-concept variable. Right? So I'm going to get some percentiles. The 50th percentile is the median, for example. Stata will show me the 4 smallest values in this variable. The 4 largest values, they're all 32. And the mean, standard deviation, variance, etc. I can add if commands. So if I want to restrict this descriptive statistics to those in region 1, I can add if region equals 1, right? And just look at the stats for those 106 kids in region 1. For categorical variables, discrete measured variables, something like region or gender, I might want to produce a frequency distribution, right? One way to do that is just type the word tabulate and the name of the variable, right? So here's a frequency and cumulative, relative frequency and cumulative distribution for this variable region, right? So 21% of kids, for example, are in the Northeast region. There's another more flexible command called table. So I could do table region, and you will just see the frequency count. There are lots of options attached to the command table that allow you to really customize tables in much more complex ways than what I've just shown you here. I could do a two-way table, so if I want to look at region by gender, I could type table region gender. Or I could do tabulate region gender. An option for tabulate is row and column. Those are two different options that will provide row percentages and column percentages. So for example, the percentage of students in the Northeast who are male and female, those are row percentages, and then the percentages of, say, male students in the different regions, those are column percentages, and those are shown in the bottom of each cell. Okay. A couple of other conditions that are worth showing you. So I've showed you the if condition with the equal sign, for example, count if region equals 1. Earlier we looked at the summarize command for self-concept. Maybe, for sake of example, I want to look at the distribution of regions for kids with a high self-concept. So let's just say kids with a high self-concept are those with a score of 21 or higher. I could type tabulate region if self-concept 08 is greater than 21. Looks like I, made a typo. Happens all the time. And there you have it. So there's the frequency of students by region for those students with a self-concept score above 21. Greater than or equal to is another condition, less than or equal to, and less than. If I would like to run a command for conditions that do not meet a particular condition, I'll use the not equal sign. Right? So let's do the self-concept descriptive statistics for kids who don't live in region 1. So I'll say if region is not equal to 1. And notice how I specified not equal to. So it's tilde equals. So this is restricted to the 394 kids who are not in region 1. There's an alternative syntax that some users use, which is exclamation point equals. That is another way of saying not equal to. Suppose I wanted another way to execute a Stata command on a subset of observations, and I want to specify those observations by observation number. So let's say I want to list ID, urban, region, and gender for observation numbers 1 through 49. So this syntax here, _n, refers to observation number. And so I could say if _n is less than 50, it's going to list the first 49 observations on those 4 variables. In our conditions, we can also use and or. So suppose I want to get descriptive statistics on self-concept for those in region 1 or 2. I could say if region equals 1 or region equals 2. Now notice that this vertical line represents the or operation condition. Right? I don't have to, but I could put this in parentheses. The and condition is the ampersand. So maybe I would like to summarize self-concept for those in region 1 and with a self-concept score greater than 21. So 54 kids meet that condition. So you want to be really careful when specifying these conditions. For example, okay, I'm going to scratch this part. So Stata has a special notation for missing values. And that notation is a period. Sorry, scratch that. Okay, so Stata has a special notation for missing values, and it depends on whether the variable is a numeric variable or a string type variable. If it's a numeric variable, the notation you want to use is a period to represent missing values. So if I were to ask Stata to give me a count of cases where parents' marital status is missing, I know this variable has missing values and it's a numeric variable, and so I'm going to say count if parents' marital status is equal to missing, where missing is a period. So 23 observations are missing parents' marital status. If this were a string variable, I would want to designate missings as an empty quotation. So 2 quotes, count if your string variable is missing. This says type mismatch because this is not a string variable. There aren't many string variables, I don't believe, in this data set, if any. Yeah, there's none. To count the non-missing observations, I could say count if parents' marital status is not equal to missing, where for numeric variables, missing is the period. So 477 non-missing cases. All right. So Stata allows you to use shortcuts called variable lists. So if you would like to, for example, output let's say the first 10 observations on the first 10 variables in the data set. So ID, well, let's just say up to self-concept 12. Rather than putting all of those variable names into the list one by one, I can use a variable list. So I can say list ID dash self-concept 12. And so it's going to show me all of those variables from ID down to self-concept 12. Right? So Stata will refer to those variable lists, or it'll treat those variable lists based on how the variables are listed in this variable window. Right? So ID through self-concept 12 will literally be the variables ID through self-concept 12 in this list. Okay. Suppose I have a data set and I want to eliminate some variables from that data set. Right? So this variable cigarette is information about whether the student has ever smoked cigarettes. If I want to remove that variable from my data set, I can type drop cigarette, and that variable is gone. Right? Again, there's no undo in Stata. You want to do this carefully. You can't recover that variable like you might in Excel, but we've just dropped that variable from the data set. Another change you might want to make to the data set is to drop cases or observations. And so what we saw earlier is that there are 23 kids with missing parents' marital status. Suppose I wanted to drop those cases with missing information on parents' marital status. If I type drop if with a if condition, Stata will drop the observations that meet that condition. So I've just dropped 23 cases with missing data on parents' marital status. Right? You want to be really careful when you're making these kinds of changes again. So I'm doing this just as a sake of example. If alternatively, I just want to keep observations that meet a particular condition, I could say keep if, say, region equals 1, and that will keep only students in region 1. So I've just lost 379 observations with that condition, that command. So now that I've totally destroyed my data set by dropping observations, I'm going to start over. So I'm going to clear that data set and go back to where I opened the data to begin with. So this use command. And I'm back to my clean data set with all of the variables and 500 observations. All right, so let's talk a little bit about do files. Right, so here's the do file editor. You can comment out lines. By commenting out, I mean Stata will just ignore those lines. So I could say example do file by Sean Corcoran. That double slash at the beginning of the line tells Stata that this is a comment. Lines that begin with asterisks are also comments. So at the beginning of this do file, I'm going to specify a working directory. You could do this in the command window as well, but I'm going to do this at the top of my do file. So the command to set a working directory is cd. So cd, and I'll put this in quotes, my working directory is going to tell Stata to change my working directory to this file path. For whatever reason, maybe I'll ask Stata to give me the version. I'm going to tell Stata to use the nels.dta dataset. By line 10 here, I'm already in the working directory. And so in this use command, I'm not going to spell out the entire working directory. I'm just going to type use nels.dta. Okay. One thing that I like to do is to go back and forth between interactive and batch mode. So if I'm playing around in Stata, issuing commands through the command window, it's logging those commands over in the review window. If there's some things that I'd like to preserve in my do file, I can select those commands. I'm just going to pick some random lines here. And I can copy and paste, or I can send selected to the do file editor. That put it into a new window. I don't want to do that. But how about I just copy and paste directly into my do file. Okay, so my do file will change the working directory, it will check the version, it will open the nels dataset, and then issue some descriptive commands. Maybe I'll add a describe in there at the top. I can save this do file just in case. You know what, I think I'll put a clear line in front of the use just to clear out any existing data. Now if I want to execute the entire do file, what I typically do is highlight the commands that I'd like to run and then click Execute Selection. You can also execute the whole file. I don't see that button. Let's see, I think that will work without anything highlighted. Yeah. So in an instant, Stata has just executed that do file, right? And if I scroll back through the output window, I will see where the do file begins here. So Stata ran the do file, changed the working directory, etc., etc. And all the results are here in the output window. Notice down here in the lower left-hand corner that it's now showing my working directory as this file location that I selected. So that will remain my working directory as long as I'm working in Stata. If I were to exit out of Stata, it would go back to whatever your default working directory is. But for now, it will stay in this folder until I make a change. I've noticed that there's some peculiarities around working in a Mac versus Windows. I'm working in Windows. One of the things that I've noticed in the past is that the slashes go in a different direction for Mac users. So you want to be attentive to that. So the next thing I want to show you is how to use a log file. So I've already shown you a couple different types of Stata files. The .dta file, that's the flat file, the data set. The .do file, that's the do file, the script of commands that you execute. But I would like to show you a log file. So there are different formats for log files. A log file is literally just a text file or enhanced text file that Stata creates and saves as you work, right? So I can open a log file, and then everything that you do while that log file is open will be saved to that log file. When I close the log file will discontinue saving output, right? This is often done at the beginning of a do file, right? So imagine I want to save, in my working directory, I want to save a log. So the command would be log using I like to use text files as the file type. So if I were to type example.txt, oh gosh, comma text, the option would be comma text to ensure that it's saved in text format. So starting at line 8, Stata will begin logging the results in the output window, and will continue doing so until I issue a log close. Right, so if I were to highlight all of this and execute it, click on this button up here, execute selection. I just ran all of those commands. Scrolling back, here's where Stata began saving to the log file. And the last command I issued was log closed, so it discontinued logging and created this log file, example.txt. I'm not sure if this will show up in the video, but oh, that's right, I saved in my data file. There it is, example text. So you could open this in a text editor. And there's your results, saved as text. Okay, this is very handy with not only with work that you may be doing in independent research, but also for problem sets for class if you want to log the work that you do. Other types of logs that I can mention, there is a file format called SMCL, that's Stata Markup Language. It's a prettier, more functional log file. It works great, but can only be opened in Stata, right? So if you want to send it to a colleague or an advisor who may not have Stata handy, you may want to stick with a text type file. Okay, a few more Stata basics. Let's talk about creating a new variable. So just for sake of example, suppose that I want to get a simple average of these self-concept scores in grades 8, 10, and 12. The generic command for creating a new variable in Stata is generate. So you would type the command generate, or maybe we'll just abbreviate it with gen, G-E-N. Type the name of the new variable you wish to create, so average self-concept, you can call it whatever you like, is equal to whatever I want this new variable to be. So I'm going to add together self-concept in 8th grade, 10th grade, 12th grade, and divide by 3. There are other ways in which you can create averages across variables. In Stata, there are often many ways to do the same type of thing, and some are more efficient than others. For now, I'll just manually add up these 3 variables and divide by 3. So now average self-concept should be an average of those 3. So I'll get some descriptive statistics on that variable plus the original 3. So looks reasonable. The average self-concept score is 25 over those 3 grades. Another useful command here is replace. So just again, for sake of example, let's suppose that I want to replace values of self-concept. Let's just do this average self-concept variable. Maybe I want to replace it with a missing value if it's above a certain level. I don't know why you'd want to do that in this particular case, but let's just say if average self-concept is greater than 30, I want to replace it with missing. So replace average self-concept with missing if average self-concept is greater than 30. Notice that I use one equals sign here. So the double equals sign that I mentioned earlier only applies after the if, as part of the if statement. So if an equals condition is something that needs to be satisfied in an if condition, use the double equals sign. If you're generating a new variable, as I did here, or replacing a variable, as I'm doing down here, it's a single equals sign. Okay, notice 98 changes were made as a result of that replace command. I'm going to drop that variable that I just created. So drop average self-concept. It's kind of nonsense anyway. All right. Suppose I want to change the name of a variable. You could do that over in the variables window, right? So if I wanted to change this variable to be self-concept 12 to self-concept G12 for like a grade 12, I could do that. It looks like that this window is currently locked. It's preventing me from making those changes, but I could unlock it just for precaution. They want to make it a little more difficult for you to make those changes. So I'm going to change self-concept 12 to self-concept G12. And notice that the command rename popped up. So that's the way that I typically rename variables rather than doing it manually here, is just type rename. So maybe I want to rename ID to ID number, NO. So rename ID, ID no. And you'll see the changes reflected up here in the variables window. At some point you might find it useful to attach notes to a variable. So I could, for example, type notes ID number, colon, and then anything you want in text following that colon. So maybe I'll just say variable name changed from ID to ID no on September 1. I don't make a whole lot of use of this notes command, but if you want to provide documentation in the data set of details on a particular variable, you can use this notes. If I type describe ID number, you'll see that there is a little asterisk next to ID number. That's telling me that there's a note attached to that variable. And if I want to view it, I can just type notes ID number. I can add additional notes. And it'll just keep adding those notes to that variable. So very helpful documentation to yourself for later uses of a data set. All right. I'm going to turn back to this parent's marital status variable for a moment. I know there's some missing values in there, and I restored the data set, so those dropped cases are no longer dropped. I'm doing the tabulate command here on parent's marital status, and I'm adding the option miss for missing, which is telling Stata to include missing cases in the tabulation. Normally it would ignore those. So there are 23 missing cases. I'm going to do a code book on parents' marital status just to show you that these categories are actually numeric values. So divorced is numeric value 1, widowed is 2, separated 3, etc. Suppose that I wanted to create a new variable called parents married. And this is going to be a dichotomous variable equal to 0 if the parents are not currently married and equal to 1 if they are. So let's just type gen married. Let's say equal to 0 if parents marital status is less than 6. So that's values 1 through 5 on this marital status scale. And now the second part of creating this command is a replace command where replace married equals 1 if parents marital status is, let's say, greater than or equal to 6. Now I'm making an error here that I'm going to explain in a second, but there is the results. And I can do a tabulation on this new variable married. It's telling me that 450 kids have married parents and 50 do not. Well, this doesn't actually line up with the tabulation on parents' marital status where 427 kids had married parents. And you might think that's strange because 6 is the highest value in this scale. And I asked Stata to replace married with 1 if parents' marital status is greater than or equal to 6. Well, it so happens that Stata treats missing values as sort of an infinitely large number. So anytime I create a condition where I say if variable name is greater than something, Stata will include missing values in that condition. So this is a really common error that's made not only by new Stata users but experienced Stata users. So be very cautious about that. An alternative way that I could have done this, I'm going to drop the married variable. Let's recreate it again as such. I'm going to change this married command to, well, I could say parents' marital status equal to 6. That would do it. Or I could say parents' marital status is greater than or equal to 6 and parents' marital status is not missing. That's a useful condition to add to commands like this just to ensure that Stata doesn't treat those missing values as meeting this condition. So tabulate this married variable, and now indeed 427 kids have married parents. All right. Sorting. So imagine I would like to sort kids by, let's say, well, their test score. So there's a variable in here which is students' math achievement in 8th grade. If I want to sort the data set from highest to lowest based on that variable, I can type sort and the variable name, and the data set is now sorted by math achievement in 8th grade. If I were to browse the data now, I'll just look at ID and math achievement. That will confirm that the data is now sorted not by ID number, which it was originally, but by math achievement in 8th grade. If you recall earlier, I showed you a case in which we conditioned on the observation number being less than 50 if I wanted to look at the first 49 observations. Notice that I've changed the sort order of the data set now. So if I were to issue that same command, I would get a different result because now the first 49 observations are different than they were when I originally sorted it. Excuse me, when I originally executed that command. I know that this data was sorted by ID number, so if I want to restore it back to its original sort order, I could sort by ID number, and we should be back to the original sort order. For whatever reason, if you want to sort in descending order, Stata requires you to use a different command, and that's gsort. So if I want to sort in descending order by math achievement, I would type gsort minus ACH mat 08, and this minus is telling Stata to sort in descending order. I'll browse just to confirm that yes, we're now sorted in descending order by math achievement. You can sort by more than one variable. So if I'd like to sort first by, let's say, parents' marital status, or let's go region, and then within region I'd like to sort by science achievement in 8th grade. I can sort region ACH science 08, and it's going to sort first by region and then by science scores. Okay, so first you have the Northeast region in ascending order, and down below you have the other regions. Okay, just a couple more things. Stata has a feature that's called by groups, and so if you want to execute a command separately by some discrete category, you can prefix a command with by. So for example, if I wanted to get descriptive statistics on test scores, so math, science, social studies, reading in 8th grade, but I'd like to do that separately by region, I can prefix the command with by region with a colon, and then summarize my 4 achievement score variables for 8th grade. Let's see if that works. Nope. So Stata wants the data to be sorted by that variable before it will execute the command by groups. And so a couple ways you could deal with that. One is to type first sort region and then execute the command, or you could just type by sort region, which is an alternative command. By sort is telling Stata to first sort by region in this case, and then summarize. I'll use a variable list this time. Reading achievement through social studies. Forgot summarize. There we go. So you'll notice that it has executed the command summarize by region, so separately by region. Okay, so one last thing I wanted to mention, which is that a really cool thing in Stata is the ability for users to write their own commands, and these are saved in what's called ado files, .ado. So let me give you just one example of those. There's a million of these out there, some of which execute really advanced statistical techniques. But let me just show you a really simple one, which is called nmissing. So I'm going to type help nmissing. This is, say, a command that I learned about when surfing the web. Nmissing is not a command that's currently installed in my Stata package, and so I see references to it, but it didn't take me to the nmissing help menu. So you can look through this list. There's actually some FAQs that make reference to nmissing. You can actually click on the website and go learn more about it. But here is what looks like the software update for down here, the software update for nmissing. So I'm going to click on that. There's information about who authored this command, a list of related files, and click here to install. So if I were to click this, within seconds it's going to install that nmissing command to my local Stata installation. The command that was issued to Stata is actually ssc install nmissing. In this particular case, it's saying that I already have it installed, which is what you just saw in the help menu. I think if I add the option replace, it will overwrite the current installation. Yeah, installation complete. Okay, so now if I were to type help nmissing, I get the actual help menu for that command. And nmissing is nice. It essentially just gives you the count of missing values for all of the variables in your data set, or a specific list of variables, or a specific set of observations that meet a condition or are in a particular range of observations. So if I were to just type nmissing, I get a quick summary of the number of missing values for all of the variables in the data set. Right? As you saw earlier, parents' marital status was missing 23 observations. Right, so that's an ado file. There are many of these and a lot of really useful ones out there. Okay, so that's where I'm going to stop for today. That's your crash course introduction to Stata. There's much more I could do. I know I dumped a lot of new commands on you. Hope this video was helpful. Thanks a lot.